Hi everyone, welcome to Data Science Monster. In this video, let us discuss about underfitting and overfitting with a simple examples. So let us consider one story. Just think that you are traveling to a new place which you have not visited before, right? So just assume that you are traveling to a new place which you have not visited before. So what we generally do, definitely you would be going ahead with a Google map. So now assume that the Google map is just showing only the main roads, but it's ignoring small streets, or if there are any obstacles, it is not showing, right? So what will happen now? Definitely you will struggle to find the way accurately, right? So now let us connect it with the data. You have data and you just build a model on it. For example, imagine you are making a linear regression model to predict the house price based upon the number of bedrooms, but you are ignoring some other important features like a location of the house or size of the house and so on. So what may happen now, if you relate with the story, it is just focusing on only certain features, not all the features. So what happens now? The model may not be able to understand all the patterns in the data. So underfitting occurs when a model is too simple to capture the patterns in the data. So what happens? There would be a poor performance on the training data as well as test data as well as in the upcoming data also. And the model is not complex enough to learn the relationship in the data. Say for example, when you implement the model, with the train you end up with a score of 45% and the test you are getting score like 44%. Now I can call this as an underfitting model because with the train it is not performing well and also with the test it is not performing well. So what are the characteristics of this underfitting? Right? So one is like a high bias, which means that the model makes strong assumptions about the data and it fails to capture the complexity. And another one, poor training also I can say. So the model performed poorly on the train set as well as the test set. Might be the data size could be very small, right? These could be the characteristics of underfitting. So now this is the example I was talking about. I'm trying to predict the price of the house. If you see that the line, correct? Like if you look into this line, maybe I cannot relate with the price of the house because you could see that it is reducing. You consider any model now. Actually, what is being expected, the line should be like this, correct? Because it is showing it should show an increasing trend according to this. But if you see that this is what it is showing. So what will happen here between, this is basically predicted, this is actual. So you can see there is lot of error, there is lot of bias, right? So if it is learning this way and if we implement it on the test data, what is going to happen? Definitely it cannot study well. Hope it is clear, right? So underfitting means with the trained data as well as the test data, it may perform badly. So how to avoid underfitting? Maybe you can increase the size of the trained data and also as far as possible, you can increase the size of the data. It could be the number of records or it could be the number of columns also, right? I will also show it practically how to overcome the challenge of underfitting. Now the next one is about overfitting. So now let's pick another story. Assume that you just pick a book, right? And you try to memorize the entire book. and you are trying to attempt the test now. So in case if you get the questions directly from the book, you may be able to answer. But in case if there is a slight deviation also, you may struggle to answer. Correct? So now let us connect with that. For example, you are trying to build a polynomial regression model to predict a house price. Say polynomial means we are ending up with a curve. And we could see that it is completely going through all the data points exactly. I can show you so that you can understand it very well, I guess. So if you look into this also now, you can see that it is passing through all the data points, correct? So likewise, if you see this also, no, it is correctly doing according to the data. So in this particular cases, what will actually happen, right? The model is too complex and it is trying to study about each and every data point. It is trying to study about the noise as well as the fluctuations also. So with the trained data, it will perform amazing, and with the test data, it may perform bad. So what are the reasons for this overfitting, or what are the characteristics of overfitting? So one thing I can say about high variance. So we have already discussed about variance, right? If you have missed that, please look into the video of bias as well as variance. So high variance, which means that the model is very sensitive to small variations in the trained data also. Then the second one, I can say excellent training performance. Excellent train performance, but worse test performance. Right? So now again, this cannot be acceptable. For example, whenever we perform model with a decision tree, we may be facing this. With the train data, it may give you 98%. For example, with the test data, it may give like 75%. This is called as overfitting model. We want only a generalized model, which means that which should not be having underfitting or overfitting issues, right? So in case if I'm having a model with a trained data 75 and test data 75, that is perfectly fine for me. This is perfectly fine, but no managers, no ML engineers will be accepting this one, right? So again, like bias and variance only, we should balance both underfitting as well as overfitting, right? Now, how to avoid overfitting? What I can do it? So one point I can say that you can always choose the right model complexity. If you choose the simple model, it may underfit. If you choose the complex model, it may overfit. We can use techniques like regularization. For example, if it is regression, I have already given a video on that, lasso and ridge regression, we call it, right? So this would be adding penalties for the complex models. Or we can go ahead with the cross validation. So what happens here? This would be helping us in evaluating how good the model generalizes to the new data by making the split in train and validation test. Again, I have given a video already in cross validation. I will try to give all the links. In case if I have missed it, please write it in the comments so that I can share it with you. Also, like as I said, decision tree, right? Decision tree always end up with overfitting. So we can go ahead with the technique of pruning, which means that we can limit the branches of the tree. And we can remove the unwanted features in the data. Instead of going for a lot of training, in case if you are working with a neural network model, instead of giving more training, we can stop it at the earliest. And we can train with a lot of data. So when we do all these steps, definitely we can overcome the challenge of underfitting as well as overfitting. Balancing underfitting and overfitting is really important when we build models, right? So the key is that we need to select a model That's complex enough to capture the data patterns, but not very complex that it learns the noise in the data, right? So this is what important. So now if you see that this is basically underfitting, you can see lot of error. It has not classified it correctly because you can see some circles here. You can see some cross here also. So it is underfitting. When I go ahead with overfitting, it is trying to learn very well with the trained data. So there is a high possibility that it will fail with the test data. If you look into this one, yes, it is coming up with some classification. Yes, there is error, but the error is very less, right? So now if you understand this concept very well, look into this question and try to answer the question in the comment. Hope this video is clear to you. So underfitting and overfitting cannot be ignored in any data science or machine learning interview. So definitely this video would be helpful to you. If you find this video to be helpful, please like, share and subscribe. Thank you so much. Let's meet in the next video.